Hey everyone, I'm Ash and this is a video with me in it called Writing Benthos Plugins. So what I'm going to do is I'm going to describe what a Benthos plugin is and why you might want to make one, and then we're just going to get stuck straight into writing the code. I'm going to build one right in front of your very eyes in real time. So hopefully you already know what Benthos is. If you don't, there's a video elsewhere outlining that, which you should probably watch first. But basically what we have is a declarative configuration that describes a streaming pipeline. And the idea is we give that to Benthos and it will just run it. And in that config we have different component types. So we've got inputs, processors, outputs, and for each of these different component types we have various implementations. So we've got a Google PubSub input here, we've got a Bloblang processor which does some mapping for us, we've got a switch output which has child outputs. Here we've got the AWS SQS one here, and the idea is that you can just write your own implementations of these component types and just build it into a Benthos instance that you keep yourself, and they will operate exactly like any other Benthos component. They look the same, they behave the same. If you were to build your plugins into a Benthos binary and give it to somebody else, they wouldn't necessarily know which component types are yours and which ones aren't, because they all work the same. So here I've got a my new plugin type, and as you can see, it's going to have its own configuration spec. And it's going to have logs and metrics and tracing and all that stuff, just like any other Benthos thing would, and you don't have to worry about any of that stuff. You just have to plunk your business logic straight into the binary. And you can also do, so what I'm also going to do is I'm going to show you how to do Bloblang plugins. So Bloblang is the mapping language, and it's got a load of methods and functions and things. And just like the component types, you can plug in your own functions and methods, and that's often an easier way of getting your code into Benthos, because they just behave in a more simple way. So we're actually going to do that first. So why would you want to do that? What? Obviously, if you wanted to build a pipeline like this, you could just do it, right? If you can write Go or any other programming language, you can write something that reads Google PubSub messages, does a bit of mapping, and writes it out somewhere. The benefits of doing it this way, where you're just taking your code and putting it into Benthos, is that you don't have to deal with the declarative configuration spec. Obviously, if you've got a configuration spec like this, then you give that binary to someone and they can change all kinds of things. They can change where data's coming from, what it looks like, what they're doing with it, all that stuff. And they can do it in a configuration way. They don't have to keep recompiling the code. You also get things like logs, metrics, and tracing out of the box. So you don't have to deal with that necessarily. You can add metrics, logs, and tracing with your plugin on top of what already is there, but you get all the basic stuff anyway. You don't have to worry about any of that stuff necessarily. And obviously, because you're putting code into Benthos, then you benefit from its transaction-based crash resiliency. So it doesn't matter what happens to this service when you deploy it, it never loses data, and you can kind of lean on those guarantees and not have to worry about solving that yourself. And that also means you get things like the type back pressure guarantees. And then finally, it comes with a cool mascot, so you don't have to worry about making a mascot for your new your new service, your thing that you're giving out to other teams maybe. That's not to say you can't have your own mascot. You're building your own binary. You can distribute it internally to other teams at your company. You can come up with your own mascot if you want to. I'm not taking your mascots away. I'm just saying that you could, if you wanted to, use the Benthos mascot. So to demonstrate plugins, I'm going to be doing a bit of role play. I'm going to be role playing as a data scientist here. This is what data scientist typically looks like. And what I've got in this role play is I've got a bit of business logic that we don't want to share with the public. This is private intellectual property, and that's why we're adding this as a custom plugin rather than contributing it to the open source project. And this is a sarcasm detector. So we take some text from the internet and then we process it and we give back a floating point number between 0 and 100, roughly describing how sarcastic that content is. Now, it's not, this function is way too complicated to dig into. A layman is never going to understand it. It's doing some crazy machine learning stuff. But basically, just trust that you get a number out that indicates roughly how sarcastic the text is. So let's stick this in a Benthos binary. Now, okay, so what we've got is a folder I've created called meow, which is going to be the name of our new project. And in that I've created a file main.go, and this is going to be the entry point for our program. And I've taken the liberty of already copy pasting my how sarcastic function. And it currently does nothing because we've got an empty main. And the first thing we're going to do is we're just going to run Benthos. So we're basically creating a shell project where we're going to compile a binary that is basically just running Benthos almost exactly as you would see it operate if you were downloading the official binary. So the first thing we should do, first thing I'd recommend anybody do, is open up your browser of choice and go to github.com/jeffail/benthos. This is the code base for now. And on here you can see what the latest release is. That's handy. So right now we're on 3.55, and that's what I'm going to be pulling in. And then in the README, there's a few different links, little badges here at the top. On the left is the Go reference link. That takes you to package.go.dev at the Benthos APIs, specifically the public directory. So this takes you directly to a list of subdirectories, and these are these are the packages within the Benthos repo that are publicly accessible for Go developers. So there's two important ones. The first one is Bloblang, and that's a fairly isolated package where you can create your own Bloblang plugins and register those, but also you can use that package to parse and execute Bloblang mappings in your own program. So you could basically take Bloblang and kind of use it in non-Benthos related projects if you wanted to. So you could use it for like document mapping and stuff in your own services. Then there's the service package. This is the one we're going to look at first, because the service package is kind of like the main business of the Benthos plugin APIs. And this is the package where you basically run the service from. So there is a function here specifically called run CLI, and that takes a context. I'll explain that in a second. But before we do any of that, I'm just going to copy paste the GitHub link, github.com/jeffail/benthos/v3, so include the major version, and I'm going to use that to add Benthos as a module. So first thing I've got to do is go mod init, because I've got to initialize my module. That creates a go mod file. I've called the project meow. It's good enough. And now I'm going to say go get, and I'm going to paste in that URL. So the URL is github.com/jeffail/benthos/v3. If you're watching this video in the future, there might be a new major version number. So when you go to the repo, just check out what's the latest one and make sure you're getting the absolute latest and greatest major version bump. So I'm just going to run that now. So what that's done is it's downloaded Benthos v3 and all of its own dependencies and cached it, and it's marked it in my go.mod that we want this dependency. So now what I'll be able to do is import it into my project. So the service package is in public, so it's /public/service. That gives us access to that service package, and then I can run from that run CLI. And I'm just going to give it a background context. So what this does, service.run_CLI, is it runs Benthos exactly as the normal binary does. So with the normal Benthos binary, you can do things like Benthos help, Benthos lint. You can just run Benthos. So all the subcommands are there, and when you call run CLI, you basically run the same thing. So you're effectively running Benthos the process, and this call blocks until the service exits. So for all the same reasons why Benthos would normally exit, either you've called sigterm or whatever. So because it's just going to block, you might not want that necessarily, so you can provide a context to use for cancellation. So for example, you could do something like go run CLI, run that on a separate Go routine, and then do some other stuff in the background. For most people, I think you're probably just going to want to run the CLI and block the process on that, and that's what I'm going to do here. So that's it. That's the main bit. I'm going to run go mod tidy now that we've got it included in our main.go file. And now what I can do is I can run go build. And what that'll do is it's going to produce a binary called meow. And I can just run that now, and it is Benthos. It may not be called Benthos, but it is Benthos, and you can do all the same stuff with that binary as you could do with normal Benthos, including things like linting, or you can create configs with this. So you can run Benthos create, you can run Benthos list to list all the different component types. And the idea is that the next thing we're going to do is start adding in our plugins, and because we've just got a Benthos binary, we can use create and lint subcommands, and it will have our plugins registered for it. So we would use this new binary for linting our configs instead of the official Benthos distribution, and that way it takes our plugins into account.
Hey, just chiming in quick because Ash forgot to mention that if you want all of the components that are in the main distribution of Benthos to be included in your custom plugin binary, you need to perform an anonymous import of /public components all. And the reason for that is because new components that are being added to Benthos are now optional. For backwards compatibility, all the old components as of about 6 months ago are always part of the binary, but in version 4 of Benthos, they're all going to be optional imports. And what that's going to allow you to do is select which components you actually want to compile in, so you're not bloating your binary with things that you know you're never going to use. So for example, you'll be able to pull in all the NATS components, and then separately you'll be able to say bring in all the Kafka related connectors. All that means for now is that if you want to guarantee that you have everything that's inside the normal Benthos distribution, then add this anonymous import, which is /public /component/all, and then you'll be fine.
Right, so the next thing we're going to do, we're doing a Bloblang plugin first. So I'm going to go to the Bloblang package, which is where you do all that stuff. Obviously, for your sake, I'm showing you this, but I don't need this because I know the APIs because I wrote them. But I would recommend checking out all these examples when you build your own plugins. But the first thing I'm going to do is I'm going to first I'm going to add the dependency, Bloblang, and then I'm going to create a plugin spec. Bloblang new plugin spec. So what this does is it creates a description of what our plugin is and what it does. So you can use a plugin spec to describe either a function or a method in Bloblang. And what you can do on this is you can add a description. That's useful if you're using your new binary to produce documentation, for example, or you might be listing in the command line. If you add a description or just add that as context. Most people probably don't need a description. The other thing you can do is you can specify all the parameters that your function or method takes, and we'll do that in a minute. I'm going to just create a plugin that doesn't have any parameters to begin with because it's simpler. So in that case, we can just have an empty plugin spec. And then the next thing is we're going to register our method. So I'm using a method just because I could make a function, but normally if you're creating functionality that acts upon values, you use a method because it's easier to sort of chain them. So I'm going to register a method. Now there is a register method function, and then there's a register method v2. I'm going to use v2. The main benefit of v2, you can use v1. It is a simpler API, but this one allows you to specify named parameters, which I'm not doing to begin with, but I will do in a minute. So I'm going to use the v2. I would recommend people use the v2 APIs, even if you don't intend to have parameters. So what you do is you give it a name. So I'm going to call this method sarcasm, and then you provide it the spec that you've created. And then what we're specifying here is a function that creates an instantiation of our method. And this will get called for every instantiation within a mapping, for every mapping that gets parsed. So we don't really need to do an awful lot in this constructor because we don't need to extract any args. If we had parameters for our method, then we could use this args parsed params type to obtain the values that we're expecting. But because we don't need to do that, I'm not going to. The signature, so a method implementation is just a function. So it takes in a generic interface type and then it returns an empty interface type or an error if the execution failed. In our case, we don't really have any failure conditions, so we don't need to do that. However, one thing I'm going to need to do is, because this method is only valid on strings, we can only detect sarcasm in string content, I'm going to need to return an error if this method is used on a non-string value. However, you don't actually need to do that yourself. You can just return a Bloblang string method, which is basically just a wrapper around that function signature, and does the string expansion for you. I'm going to return a nil error because there's no error conditions in our constructor. So you might return an error during the construction of your method or function if you get parameters with values that don't make any sense. So if you're going to do some extra validation, because you outline the parameters within the plugin spec, then most issues, like if you have a string parameter and somebody puts an integer in there, then you'll get an error returned at parse time, and you don't have to do that yourself. But for example, if you have a string parameter that needs to fit a regular expression or something, you might return an error within the constructor for that. But in most cases, you probably won't need to return an error within your constructors. And then finally, within the body of my method, all I need to do is call my howSarcastic function. So I'm going to return howSarcastic on the string, and then a nil error because we're not going to have an error. So that's going to return a floating point number, and that's fine, that's valid. So valid Bloblang value. So that's it. That's actually it. That's the entirety of our plugin implementation. So I can build that. And now my meow binary is going to be Benthos with this new method. So the easiest way of showing that is, so you can run Bloblang directly on the command line with the blobble subcommand. So I'm just going to do something like root.s. We're going to create a new field s in our document is equal to this dot foo dot sarcasm. And now I can input a document. So we're expecting a field foo, and this is not sarcastic. So if we feed that document in, we get one out where s is 0, which is what we expect because that content was not sarcastic. However, if I go this is not sarcastic /s, whoa, suddenly that's sarcastic. That's so sarcastic. I can't believe. We can also do cooler things. So with Bloblang, you can do some pretty cool stuff. So we don't even need structured data if we don't want to. So what I can do is I can assign the result of sarcasm directly to the root, which means we're just going to get a raw number spat out. And also similar, we can consume non-structured data just by referencing the raw content and calling sarcasm on that. So that allows me to do stuff like hello world, that's not sarcastic. Hello world, that is sarcastic. That's really sarcastic. We can also actually run a Benthos config. So let's do meow create. So we're going to use the create subcommand to create a Benthos config where we're just going to read from standard in, do a Bloblang mapping, and then write to standard out. So this is actually going to create a config that does the exact same thing as what this command line is doing. It's going to read from standard in as our input, write to standard out, and it's going to execute some Bloblang. But doing it this way does allow us to have a slightly cooler mapping. So I can do something like root.s equals this.foo sarcasm. I'll tell you what, let's foo s equals this.foo.sarcasm, and then bar underscore s is this.bar.sarcasm. So we're going to expect two string fields on our input document, and we're going to detect the sarcasm on each of them and assign that to these new values foo.s and bar.s. I'll tell you what, actually as well, we'll copy all the input fields in. So the resulting document will be a superset of the new fields and the old ones. And then I'm also going to do, I'll tell you what, actually, we're going to work out how sassy the user is. And the way that we're going to do that is we're going to create let foo s equals this.foo. We're We're going to capture the sarcasms into variables so that I can reference them twice. And then we're still going to assign foo and bar underscore s to the value of these variables. And then sassy is going to be whether foo.s is greater than 0 or whether bar s is greater than 0. So I'm going to create 3 fields. Foo underscore s is the sarcasm of foo, bar underscore s is the sarcasm of bar, and then sassy is a field that we're putting in. It's going to be a boolean, and it's going to be true when either foo was sarcastic or bar was sarcastic. So let's see if that runs. Meow, execute test.yaml. So we've got some logs, that looks fine. So I'm going to add in a document where foo is just hello world, and then bar is also just hello world 2. And what we get out is bar is hello world 2, and foo is hello world 2. So we've got what we fed in back out, but then we also have this bar underscore s is 0, so not sarcastic, and foo is also not sarcastic, and therefore sassy is false. This user is not sassy. If I just do the same thing, but I make bar sarcastic now, what we get out is not sarcastic. Oh, there was a bug in my mapping. That's why. So bar underscore s is this dot bar dot sarcasm, not foo dot sarcasm. So let's run that again without bugs this time. And there we go. So bar is hello world 2, and bar underscore s is 100 because it is sarcastic. Foo, on the other hand, is 0. It's not sarcastic. And sassy is true because at least one of those strings was sarcastic AF. We're not having that. We're not tolerating that. Similarly, I can do that with foo and not bar. And sassy is still true, even though foo is the only one that's sarcastic. And obviously, if both of them are sarcastic, let's get 100% test coverage, please. And yeah, sassy is true. That is sassy AF. So what I'm going to do now is I'm going to add a parameter to my method. What I'm going to allow you to do in the mapping is specify specifically what the indicator is. We're going to call this indicator of whether or not something is sarcastic. So yeah, why not? I'm going to add a parameter to my spec, and this is a string parameter. I'm going to call it a name, give it the same name as our thing, and you can do things like give it a default. So if you define a parameter and you don't give it a default and you don't mark it as optional, then it has to be specified in the mapping, otherwise the mapping fails to parse and you get an error back. If you give it a default, then it becomes implicitly optional, and the default value is assumed if it's not overridden by a user in a mapping. Or you can mark it as optional without a default and it's explicitly optional, in which case if it's omitted and there is no default, then you get a null value and you can detect that in your constructors. So in my case, I have a field indicator and I've given it a default, so I don't need to worry about any other stuff. And then the next thing to do is to extract it from my parsed spec. Sorry, the parsed args. So I'm going to call get string indicator, and the name needs to match. If does not equal nil, go errors are great. So there are errors returned by these get functions. The only error condition, because the parameters are validated before the constructor gets called, and better error messages are returned than what you would do in your constructor. There's not many cases where an error might occur here, except for the case where there's a disconnect between the naming. So you've messed something up in your plugin spec or whatever. So you could ignore those errors, but don't. I would recommend always checking them. So now we have our parameter, which is now a populated argument. and we can feed that into our howSarcastic function. So that's it. That's all we have to do. So now if it's not specified, we get /s like before, but if it is specified, then we get this new thing. And all that's going to do is allow somebody in their mapping to override that in the case where they have some other convention for detecting sarcasm. So I understand that I'm kind of exposing the special source of my sarcastic function here, at the risk of being fired for not building anything of value. I've basically just wrapped strings.contains, but just don't tell the boss and it will be fine. So what I'm going to do is, so because it's a named parameter, I can have a named parameter in here, and I can put whatever I want in this. I'm actually going to use meow as my custom indicator for whether bar is sarcastic or not. And I'm going to leave foo as it is, the /s default. Now, in this particular case, I actually think named parameters is a bit overkill here, so I'm just going to use anonymous arguments. And what that means is the order in which parameters are registered in your plugin spec. If you follow that order with anonymous arguments, then you're all good. And it basically just means you can have either convention. And that's it. That's what I'm going to run now. So I'm going to build that first, because it would be embarrassing if I forgot to do that. And now if I run the same content as I did before, where both strings contained hello world /s this is, we should see that bar is no longer considered sarcastic because we have a custom indicator. So I'm going to override the previous one. So I'm going to say yo meow, and now bar is sarcastic. So it is using our custom indicator. So that's it. That's all you need to do. So now if you were some employee at an organization, you need to give some team access to a Benthos instance with some custom logic in it. This is pretty much all you need to do now. Now the job is set up some CI to build this project, and then distribute the binary, which is fairly straightforward because it's just a static thing. Next thing is, this is the recommended way, I would say, of doing any sort of Benthos plugins. If all you want to do is add in some sort of kind of isolated synchronous logic. If you need to do things like network calls, where you have kind of a concept of a lifetime, you're managing connections and stuff like that, and you need to have like an explicit construction and tear down of the components that you've built, then that's when it's worth putting a little bit more time into building a processor plugin rather than just a Bloblang function. It's not going to be as flexible because obviously Bloblang methods and functions exist in a mapping, so you can apply them in all kinds of different ways, but processors give you more control over what's actually happening in the background, and resources and things. So that's what we're going to do next. I'm not going to do any input or output or cache and all that stuff plugins in this one, but they are very similar to processor plugins. Okay, so I'm going to get rid of all this junk because we've kind of outlived our sarcasm detection function. And the first thing I'm going to tell you is to read the documentation. So there's a bunch of examples for all the different component types, the Benthos component types. So inputs, outputs, processors, caches, all that kind of stuff. So if you want to author a plugin, this is what I recommend you do. You come here, you look and see if there's an example. There's also a repo for demonstrating some plugin examples. That's not going to be as exhaustive, I don't think, as I'm going to keep these examples up to date, and I'm going to keep adding more. The other repo is just kind of like a template, I guess. But all of these things are going to be linked in the description. What I'm going to be doing is a processor plugin, and all of this stuff is within the service package. So the first thing I'm going to do is a spec service new. So for component plugins, the thing that we spec is the configuration of the component. and it looks very, very similar to a plugin spec for Bloblang. So we have an empty config spec is valid if we don't have any parameters for our plugin. But we can add fields, so configuration fields, and these are very, very similar. So, you know, new string field, very, very similar to Bloblang. I'll tell you what, we're going to add a few fields to our processor. So what I'm going to do is, let's think about this. What am I going to do? What is our processor going to do? We're going to create a meower, okay? It's going to be called meower, and it's going to add a certain number of meows to the input document, okay? So we're going to have a field, it's going to be an integer field called count, and that's going to be the count of meows. Now we could do things like add a description. Again, this is for the configuration documentation generation. You don't need to add descriptions for any of this stuff. You can also do examples, which is a fun one. That allows you to do to list documentation examples for your fields and components, and that'll get put out in the documentation. And you can also specify default. So if you specify default, then it makes the field optional. Otherwise it ain't. And we're not going to have a default for this one. You have to specify count. And then there's also stuff like advanced. So that's just a documentation thing again. So if you were generating configs, you can choose to generate a simplified config without any advanced fields. So if it is an advanced field, then mark it as advanced, and it'll make the generated configs a little bit nicer. And let's add another one, which is a string field. And we're going to call this the meow. And this is going to indicate what type of meow our component is going to add. So we're going to add a certain number of meows to the content, and this is going to allow you to override the default, which is just a meow. So for example, you could add meow meow, you could add meow, or you could even add meow if you wanted to, but we're just going to do a classic meow as a default. So that's going to be an optional field. And then that's it for our spec, I believe. So now we're just going to register a processor. We're going to give it a name, meower, and we give it the spec. And then we add a constructor. So the constructor is very, very similar to Bloblang plugins, where we get a parsed version of the configuration/argument spec. And that's where we extract the fields. And then we also have this extra thing called a resources manager thing. I'll explain what that is in a second. And then what we need to give back in our constructor is either an error, if we're not happy bunnies, or this processor interface. This is more complicated than just the function that we had to return for Bloblang. But it has things like a close method on it, which I'll show you in a second. So in order to return one of those, I'm going to have a special type. So let's call this our meower. It's going to be a struct, and it's going to have the same parameters as below, because this is what we're giving those parameter values to. So we're going to have a count and a meow type, and then what we need to do for this is implement the service.processor interface. So I'm pretty sure there is a generate interface stubs service.processor. Is VS Code going to do it? God, it did something. Kind of. It made a mess, is what it did. Okay. That's kind of what we wanted. Not really. It would have been easier just to type this out manually. So what I've done is I've got the signatures now for the interface that we're implementing. And these are going to be pointer receivers. Doesn't need to be actually, but for most meaningful implementations of processes, you can have pointer receivers. Right, okay, so In the functions we've got here, I'll explain what these are and what they look like, but first I'm going to finish my constructor here. So we need two parameters. We have count, which I shall extract, field int count, and if an error came back, then we return the error. Similarly, we're going to have a meow type, field string, sorry, that's a meow, and then I'm going to return my meow type with a count, meow type, and then meow. So this is a very, very bare bones, let's neaten this up so it all fits. This is a very, very bare bones constructor and processor implementation. So you'll notice that we haven't got any sort of logging or metrics stuff going on here. That's because you don't need to. So when you create a plugin type, it kind of gets wrapped in a component that does basic metrics and basic logging. So if you return errors during processing and stuff like that, then it logs and increments metrics counters for all of those occurrences. So you don't have to do any sort of observability stuff in your component if you don't want to, only if you want more granular metrics. And if you do want to do that, then what you can do is you can use this manager that gets provided within the constructor, and that gives you access to a logger, which is the service-wide logger. So it's the same log configuration as the rest of the service, and similar with metrics. So the reason why you would want to use this is because in a Benthos configuration, you can obviously specify how metrics get exported. So is it Prometheus, CloudWatch, StatSteel, that kind of stuff. And if you use the provided resources type, then it means that your plugin is always doing the right thing according to that configuration. And this gives you access to create counters. You can do a new counter, gauge, timer, all those kinds of things. But we're not going to be doing any of that stuff here. And to be honest, most plugin authors, you don't really need to do any of that stuff. The metrics that are already done for you cover most things. So it's got count, errors, and for some components there's latency and stuff like that as well. And that's, I think, it. We don't really have any error conditions. Any meow is a good meow. Any count is a good count. We probably ought to check that this is at least, I'll tell you what, if count is less than or equal to 0, we return an F error. You can't have a meower without any meows. We're not going to insult the user, so we don't need to do any formatting. Right, so if you specify count that doesn't have a satisfactory value, then we tell you off, basically. And yeah, that's it for our constructor. That's all I'm going to do here. And then for every instantiation of our plugin, so every time it appears within a config, this constructor is going to get called. We're going to get a brand new meower for that particular instantiation with its own parameter values and things. And then what we would do here normally, so if we have like resources that need to be constructed, so say we need to establish a connection somewhere to some sort of service, we might do that in the constructor here. Maybe we create a nice convenient, new meower function that would essentially create those connections and do error handling and stuff like that. Maybe ping the service or something and make sure that it's up, so that when we begin the streaming pipeline, all that stuff's ready to go. But in our case, we're not doing any complex stuff. We don't really need a processor plugin for this. We could just have done this as a Bloblang method, but it's too late now. We're committed to our processors, so we're just gonna have to deal with it. So process, I'll do that in a second. So close is a method. So this is gonna get called when Benthos is done with the component. So under normal operation, that's probably only going to happen once during the life cycle of the process. So you start Benthos, it kicks up a stream pipeline, and the constructor gets called, and then the processor is processing, and then at some point maybe the service gets gets a sig term, told to shut down, and then it gracefully shuts down. And it won't do that until it's called close on all the components in a graceful way so that messages can be flushed all the way through the pipeline. So you would normally expect to see this once. However, there are lots of reasons why you might have processes being constructed and then torn down and then constructed and torn down and so on and so forth throughout the life cycle of a Benthos instance. So for example, if you're running it in streams mode and therefore you're using the streams REST API for kicking off, stopping and monitoring stream pipelines, then there might be lots and lots of processes being started and stopped within the lifetime of a single binary. Also, if you have resources, so resources can be similarly started and stopped and things. So what I'm saying is your close implementation should block until all the resources used by your plugin implementation are shut down. So if you have connections to things, so say you have like a Kafka connection or MQTT or something like that, or maybe you have a WebSocket open to some service, you shouldn't return from close until all that stuff has been deleted. It's not really that big a deal if you do it in the background and it happens eventually. It just means that in a particularly aggressive case where you have maybe Benthos running in streams mode and it's constantly churning through processes, bringing them up, tearing them down, bringing them up, tearing them down. I'm not really sure what the use case is. You could end up, using a lot of memory that way and it not being a very efficient thing. But generally, I don't think you need to worry about it that much. But just remember that within close, you're meant to essentially shut down your component. But obviously, if you don't have anything to shut down, just return nil and don't worry about it. So in our process function, so what this does is it receives a message, and that has methods for things like, we've overloaded M. So message, so you've got a bunch of methods on this. So you can do things like extract the contents as a byte slice. So that'll be the raw bytes of the message. So if it's a JSON document, you'll get a JSON string as a byte array. If it's just raw binary data, then you'll get that binary data. You can also extract it as a structured document. So that can return an error if it's not structured. If you're expecting a JSON document and you call that structured, then it basically is it's lazily parsed as JSON. So if it's already been parsed by another component, then you just get back the empty interface type, which will be a map string or whatever the value of the JSON document is. Or if it hasn't been parsed yet, then it'll get parsed at that point. So it's kind of like a lazily evaluated JSON parser, and other formats as well, depending on what kind of thing you're consuming. We're not going to be bothered about that. We just want the bytes contents. So I'm just going to go message as bytes. And if there's an error there, there's not really any situation where this would realistically return an error. The only case where it would is if you have a plugin that came before this plugin and you populated a message with some weird type that cannot possibly be serialized. Because again, as bytes is lazy evaluated just like the structured method. So if the message is already just raw bytes, or if it was a JSON document that has already been serialized to raw bytes, you just get those bytes and nothing happens. It's free. Or if it's a structured document and it hasn't been serialized yet or marshaled or whatever we want to call it, then it happens then. So if it's a JSON structured document or something like that, or Avro or whatever, and it hasn't been marshaled into a byte slice, then it happens at this point. So in theory, you could have populated a message with something that can't be serialized, passed it downstream, in which case this could return an error. So you should capture this, don't ignore it, but also don't worry about it. So I'm going to end up doing some stuff with my byte slice, but let's just mutate our message first. So what I'm going to do is I'm going to end up modifying, oh, we've got fireworks. I'm going to end up modifying the contents with my meows, and then I'm just going to set the original message that I received. I don't want to make any more changes. I don't want to clone it. I've got one message coming in, and I'm resulting in one message. So I'm just going to set the bytes, and then what I'm going to do is I'm going to return a message batch. So why do we do that? Why do we have message batch on the output when we only receive one message? Well, the simple answer to that is because we might want to create more than one message as a result of our process. So we could receive one message in our processor and then have several depending on the contents. And what this signature allows us to do is expand messages. And what happens is, because Benthos operates in a sort of transaction model, it means if a message comes through the pipeline, so say we read a Kafka message, if we have a processor that expands it into multiple messages, all of those resulting messages are kind of tied to the origin message. So that original message is not acknowledged from wherever it came from. It's not acknowledged until all the messages that were essentially extracted from it have all been sent downstream. And once they have been sent downstream, then it can be acknowledged. So what's actually happening here, this is quite a simple method signature, but what's actually happening is we could be reading a message and expanding it, and then all this cool stuff is happening in the background where we've got tight delivery guarantees that ensures that even though we've expanded our message and it is getting fanned out, all those resulting messages could get routed to different outputs. Some of them could get filtered, some of them could get dropped, all that stuff. Basically, the origin message isn't acknowledged until all of those resulting messages have ended up somewhere. So they could have been filtered intentionally, in which case that still allows the original message to be acknowledged, or they've been sent somewhere. All that good stuff. What I'm saying is you don't have to worry about it, okay? Benthos has your back. And that's why we were allowed to send a message batch. But most of the time, you're probably only going to be sending a single message batch, a single message back. So you just have a message batch of size 1.
Hey, just want to clarify some extra bits that Ash has missed here. If you return an error in this function signature, it's a processing error, which means the message is flagged with an error but isn't dropped. So it gives you a chance in config to decide what to do with that errorless message. So you can either recover it with some other processing, or you can route it to a dead letter queue, or you could just filter it if that's what you want to do in the end. The other thing you can do is return a batch that's empty. So return 0 messages and a nil error, and that ends up acknowledging the message as an intentionally filtered message. So you can choose to remove messages and acknowledge them.
There is another processor type that you're allowed to make called a batch processor, which I'm not going to go into here, but that actually allows you to receive a batch of messages. So normally if you're processing batches, then you'll do some sort of like windowing at the buffer layer. There's documentation on the site for stuff like that, or maybe you're reading from Kafka and you're batching stuff at the input level. And a batch processor allows you to process the entire batch, so you can do kind of windowed processing with it, and then that can result in one or more message batches. So you could have multiple message batches coming out and all being routed, and still the delivery guarantees are all neatly tied and handled for you. Right, enough waffling on about that. Let's actually implement some stuff here. So what this is doing right now is it's just passing the data through. It's extracting the bytes from the message, and then it's putting them back in, and then it's sending it onwards. That's not particularly interesting. So what we're going to do is we're going to create our meows and append them to the byte slice. So what I'm going to do is b equals append b. Now you're not supposed to modify the underlying slice here. So you can modify the message, and that's fine, but you shouldn't modify the raw bytes themselves. So what I'm going to do is I'm going to create a new byte slice. I'm actually going to create a buffer. Buff write our bytes contents, and that might return an error. Might do. In which case, we'll exit. Let's keep that nice and tidy. And then we are going to write more stuff. So we're going to write let's write a string, strings strings.repeat. And we're going to repeat the meow that has been configured count times. And that can probably also return an error. Is that just to match the writer's signature, or is that actually something that can fail with a buffer? Question for another day. And then what we're going to write is the bytes from our buffer. And then that's it. So we could optimize this during our construction. So in the constructor here, where we've extracted our parameters, we could call strings.repeat and then just use the result when we're adding to our buffer. I'm not in the market for optimizing stuff. I don't understand any of this code. It's too confusing. I'm just going to do my repeat here where I feel comfortable about it. And that's it, I think. Is that it? We've meowed a number of times, added it, and yeah, I think that's it. Okay, so let's do it. Let's build our new meow service. So what I'm going to do is I'm actually going to create a config with that in. So we're going to do standard in, what is it called? Meower, standard out. And we're going to pipe that into test.yaml. Oh, sorry. I don't have meow installed globally. So let's see what it created. Did it create the right thing? So we've got standard in on our input. We've got standard out on our output. And look at this. The generator, the create command, has created for us a meower processor. And it's pre-populated some values here. So we've got count is 0. And we have a default for meow, which is just meow. Interestingly, so count is mandatory, but it does give us the value in the generated version. If I commented this out, whoops, sorry. If I comment that out and I lint my new config, it should give us an error. So yeah, line 11, field count is required. So you better add it. If I add it in, we should pass the linting. I could add a linting check to make sure that we're above 0, because actually that's not going to run. Let's do it. Meow. Let's run my config. It should tell us you can't have a meower without any meows. You're right. We can't have a meow without any meows. So let's add one. Count 1, and now hello world. Hello world meow. So what you're going to notice, if we increase the number of meows dramatically, we don't have any spaces in there. So what we can do is we can customize our meow in order to add some spaces. And there we go. Hello world, meow, 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 meow. And let's do it again. So because this is a processor, we can chain them. So we can have one that executes. So we're going to add 5 meows onto the end of our message. And then this next one, let's add some exclamation marks. Exclamation, exclamation 1. And we're going to do that 3 times. And then we're going to have another meower. Oof, that's a lot of meows. With 8 more. And this is going to be woof this time. So we're going to have quite a lot of meows, a bunch of exclamation marks, and then some woofs. How's that sound? So we're going to do hello world again. And then, whoa, look at that. Hello world, meow, 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 meow. Woof, 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 woof. And that's stream processing. What else is there to do? I think that's it. I think we solved it. I think we've solved data engineering, and I think we can take a break on that. So I think I'm going to wrap up this video there. There's lots more to cover. So how do you unit test your plugins? How do you write inputs and outputs efficiently? Are there any caveats to any of this stuff? All those are things that I can cover in future videos, but my default is to not be bothered to do that. So if you would like to see some of that content, let me know. There is a way to do that on YouTube. There is a comment section underneath the video where you can express yourself and your thoughts and opinions. And those are really important. And you can also, there is a little icon which looks a lot like a thumbs up. And thumbs up is a gesture generally accepted to mean that you appreciated something. And if you appreciated this video, maybe you would find it upon yourself. I'm not telling you what to do, but maybe you would find it upon yourself to click that button. There's another button as well, a little bell icon, sometimes called subscribe, where if you are in the market for videos of this nature, then you can click that and it'll make it more convenient to discover videos like this. Thank you for watching. Hopefully this was useful and not too emotionally taxing on you. I've been Ash, and I'm going to put a load of info in the description, so if you feel like there's gaps, then there'll almost definitely be a link in there that covers your base.